Jai Bharat to all students. In last lecture, we have studied a revision of all the previous chapter of graphs. Okay, so and last to last lecture, we have discussed some very important topic, metric representation of graph. Okay, so it's a very important topic. Okay, so you have to understand it properly, and in exam also they have asked the question related to matrix representation of graph. Okay, so now in this lecture we already have discussed about other definition of graph. Okay, so till now we have seen number of definition related to graph. Okay, so it's a you have to study the graph related definition. Okay, so in this lecture also we will discuss about 5 to 6 definition related to the graph, different types of graph. Okay, so let's start. Okay, first of all, null graph. Okay, as a word say, null means zero. Okay, null graph means a graph whose edge set is empty, not vertex, edge set. Okay, there is a no edge in the graph. Okay, it's called null. Okay, so each vertex of a null graph is isolated. Yes, we already know, and we can donate the null graph of n vertices by na. Okay, so null means n and number of vertices is 4. This is a n 4. If it is a, let's say, 5 here, so it will become n 5. Okay, how many number of vertices are there? And null means n. Okay, so we can represent like this null graph. Okay, it's easy. Okay, then complete means is itself word said this is a pure complete. Okay, completed graph. Okay, it's a simple graph when each pair of distinct vertices are adjacent. Adjacent means near. Each pair of vertices is near is a complete graph. Okay, so it's connected with the edges, all the edges with the vertex. Okay, so it's cell this vertex is connected with all the vertex. Okay, this also vertex is connected with all the vertex. Okay, so in simple word, complete graph means each vertex is connected with its adjacent vertex. Okay, there is a you can do not draw any new edges joining between them. Okay, so this for this graph there is no possibility that you can draw a new edge. Okay, it's a simple, so you can do not join you can connect multiple edges. Okay, so it's simple graph with each vertex is connected with the other adjacent vertex. Okay, here also this is also this vertex is connected with all the 4 vertex. This vertex is also connected with all the 4 vertex. Okay, so this is a complete. Okay, you cannot draw any new edge with the any vertex. Okay, complete means it's a full. Okay, complete graph. Okay, so if we want to denote the complete graph of n vertices, we can denote like this: k, not c, k, k n. How many vertices are there? Means this is a k 4 and this is a k 5. 5 vertices are there. Okay, now how many edges? Total number of edges are there? K has a 1 by 2 n into n minus 1 edges. Okay, 1 by 2 n into n minus 1 edges, number of edges. Okay, let's say k4. So if you put 4 by 2 means 2 and 4 minus 1 3, 2 into 3 6. Okay, 1 2 3 4 5 6 edges here there. Okay, so for this formula you can also find out that how many edges, total number of edges are there for the 4 vertex. Okay, also for 5 5 by 2 and 5 minus 1 4, so 2 2 5 into 10 10. Okay, so you can count this edges and it will always be 10. Okay, so complete graph can has a 1 by 2 n into n minus 1 edges, number of edges. Okay, next, cycle graph, path graph and wheels. Okay, let's see. A connected graph. Okay, first of all they have to given connected. Okay, it's called connected. Okay, it's not open like this. Okay, it should be connected. Connected graph in which each vertex has a degree too. We already know how to find the degree of vertex. Number of count with the edge for particularly vertex is a cycle graph. Okay, number of degree of vertex is equal to 2 each vertex. Okay, and we can denote a cycle graph as a Cn. Okay, so for cycle graph is a C, for complete graph it's a denote like K. Okay, Cn. Okay, so this is a C 1 2 3 4 5 6 C 6 cycle graph. Okay, each vertex has a number of degrees 2. Why? Because one edges and two edges. Degree of vertex is a 2. Now path graph means the graph obtained from Cn cycle graph by removing an edge. You have to remove one edge is the path graph of n vertices. Okay, it's a cycle graph but you have to remove one edge. Okay, let's say I have removed this edge. Okay, so and I will put same line, give a name 1 2 3 4 5 and 6. Okay, I have removed this edge, so 1 2 3 4 5 and 6. Both 1 and 6 will have only 1 degree vertex. Why? Because we have removed one edge. Okay, so it's a called path. Okay, it's a cycle but you have to remove one edges from the cycle graph. Okay, then wheel graph, the graph obtained from Cn minus 1. You have to remove one vertex and by joining each vertex to a new vertex V. Each vertex to a new vertex V is the wheel on n vertices. Okay, let's say I have removed this 6 number vertex. Okay, 6 number vertex. Okay, and again I have to add new vertex V, but V is the connected with the all the vertex. Okay, it's connected with this 1 2 3 4 and 5. First of all you have to remove one vertex, then you have to add new vertex, and this new vertex is connected with the each vertex. It's called wheel graph. Okay, and it is denoted by VWN. Okay, so this is a cycle graph, this is a path graph and it's denoted like P6, and this is a wheel graph. Also we have 6 vertex, so W6. So cycle graph, path graph and wheels. Okay, cycle, path and wheels. Then regular graph. Okay, regular graph, a graph in which each vertex has the same degree. Okay, same degree. In previous we have discussed simple graph. Okay, not regular graph. So regular graph definition is there that number of degree of vertex should be same each vertex. Okay, it's called regular graph. Okay, let's say if each vertex has a degree r, then graph is a regular of degree r, or you can say r regular. Okay, and null graph is also a regular of degree. Yes, because why? Because each vertex has a degree of vertex is 0, no edges. Okay, so null graph is also a regular graph. Cycle graph is also a regular of why? Degree of vertex is all the vertex of degree of vertex is 2. In definition we have given that each vertex degree is 2. So cycle graph is also a regular graph. Okay, and the complete graph like this. Complete graph is also a regular graph. Okay, Why? Because we have completed graph, so this vertex has the same number of edges. So this is also a regular graph, and regular of degree n minus 1. Okay, one edge less. Okay, if there is a 4 vertex, then number of edges, degree of vertex is 3. Okay, so n minus 1. Okay, so till now we have studied complete graph, cycle graph, path graph, and wheel. In which a complete graph, it's also a regular graph. Null cycle graph is also regular graph. Okay, also some special importance are the cubic graph. Cubic means 3. We already square and cubic are there, so cubic means 3, which are regular of degree 3. Same but regular of degree 3. If it is a degree is 2, then it's we call cycle. If it degree of vertex is 3, we can call as a cubic graph. Okay, so this is a cubic graph. Okay, each vertex has a number of degree of vertex 3, 1, 2 and 3. Also you can count for this vertex 1, 2 and 3. You can count for this vertex 1, 2 and 3. Number of degree of vertex for each vertex is a 3. It's called cubic graph. Okay, so for regular graph, same degree of vertex, all the vertex has a same degree. Next, platonic. Okay, what is platonic? Platonic is a regular graph but formed from the vertices and edges of 5 regular platonic solid. Okay, we already know what is the solid: tetrahedron, octahedron, cube, isohedron and dodecahedron. Okay, so this is a 5 regular platonics itself. It's a different name, but you have to remember like 5 regular platonic solid. If we can convert a regular platonic solid into a graph, then we can also make the regular graph, and it's called platonic. Okay, we have convert this into one graph, in 2D graph. Okay, this octahedron into this graph, this cube into this graph, 2D graph. Okay, so it's called platonic, but it's a regular. Okay, so number of degrees is a same. Okay, you have to remember the number of degree of each vertex is a same. Okay, for here in tetrahedron, number of degree of vertex is 3. For octahedron, number of degree of vertex is 4. For cube is say 3, number of degree of vertex 3. Isohedron, number of degree of vertex 5. All the degree of vertex is a 5. And dodecahedron, all the degree of vertex is a 3. Okay, number of degree of vertex is 3. Okay, so it's a regular graph but made from the platonic solid. Okay, this is a platonic solid made from platonic solid, so it's called platonic graph. Okay, platonic graph is a regular graph. Then here some of the name is difficult to pronunciation. Okay, but it's a concept. Okay, it's easy. Okay, so if you read or write 3 to 4 times, you can get the better idea. Bipartite graph, bipartite graph, bipartite. Okay, if the vertex set of graph G, let's say vertex set of graph G can be split means divided into 2 disjoint sets A and B. Okay, we have to split 2 graph A and B so that each edge of G joins a vertex of A and vertex of B. Okay, each edge join with the vertex of A and vertex of B, then G is the bipartite graph. Okay, let's say here for this dark circle is a graph, this blank circle blank vertex is a B graph. Okay, so if we split into 2, this is a and this is a B. Okay, so G joins a vertex of A also and vertex of B edge also, each edge. join with vertex of A and vertex of B. Okay, so this vertex is connected with the like this. Okay, each edge connected with A vertex to the B vertex. Okay, no one should be remain. It's called biparated graph. Okay, so for the difference we have to color black and white so that each edge joins a black vertex in A, and while vertex in B we sometimes write like this, G of A and B. Okay, sets an A and B. Okay, so it's called biparated graph. 5 vertices and 5 edges, and each edges is connected with one vertex of A and vertex of B. Okay, now in biparate graph there is also one complete biparated graph. Complete biparated graph. A complete biparated graph is a biparated graph in which each vertex in A is joined to each vertex in B. Each vertex in A is joined to each vertex in B by just one edge. Here you can see that for this biparated graph, here this vertex is connected with 3 edges. Sorry, 2 edges with the one vertex. Okay, but complete biparated graph means it's a biparated graph in which each vertex in A is joined to each vertex in B by just one edges, no multiple edges. Okay, it's called complete. Okay, so this is a A set, this what is B set. It's connected with only one edges and each vertex. Okay, connected have to each vertex. Okay, it's called complete. Complete means no any edge you can draw. Okay, here you can draw one edges like this also, like this also. Okay, so this is not a complete graph. Okay, so for complete you have to remove this first edges, then you have to connect it with these two edges, then you can say this is a complete biparated graph. Okay, for complete each vertex is joined with the only one of edges. Okay, so we can denote the complete biparated graph with R black vertices and S white vertices, KRS, like this. Black, first of all we have to write down black vertices and then white vertices. Okay, so here black vertices number of vertices 1 and white vertices number of vertices 3, K1 3. This graph is K in suffix 1 and 3. We have 2 black vertices, so K2 3. We have 3 black vertices and 3 white vertices, so K3 3. Here you can see that each vertex is connected with the only one edges. Okay, and is connected with all the white edges. Okay, it's not compulsory that these 2 black edges have to be joined. Okay, vertex A and vertex B is connected with each vertex. Okay, it's not necessary that set of vertex A has to be joined. Okay, each vertex in A is have to connected with the vertex B. Okay, this is the K for 3, 4 black vertices and 3 black vertices. Okay, so it's called complete biparated graph. So we have now studied 5 to 6 new definition related to the graph: null graph, complete graph, cycle graph, path graph and wheels. Regular graph has the same degree of vertex. Platonic graph, and then biparated graph, in which we have already discussed complete biparated graph. Okay, complete biparated graph. Okay, okay, let's discuss exercise. Okay, this is your also it is your question for assignment purpose and attendance purpose. Okay, we will discuss this. You have to draw the following graph like this: null graph of n5. Okay, simple. Null graph means only 5 vertex, no edges. Okay, so it's a simple, you can draw null graph. Then complete of k6. This is a 1 2 3 4 6. Okay, each vertices is connected with the each vertices. Okay, like this. Anyone remaining? No. Okay, so each vertex is connected with the each vertex. It's called complete. You can do not, after complete graph, you can do not draw any new edges between vertex. Okay, so this is a complete graph. Then complete bifurcated graph of k24. Okay, you can draw, this is a k23. Okay, you can add one here white. Okay, so this is a k24. Okay, you can make like this. Then union of k13 and w4. Okay, first of all you have to draw k13 and then w4, and you have to make union. We have discussed in third or fourth lecture. Union means you have to add addition of two graph. Okay, so first of all, what is a k13? K13 you can draw like this. Yes, k1 here, this is a k13, one black, 3 white. Then wheel of 4. What is a wheel? We have to first of all draw a cycle graph of 4. Then we have to remove one graph and we have to add center and joining with each vertex. Okay, so cycle graph of 4. So let's say 3, and in one is a center. Okay, so this is like this, and this center point is connected with the all vertex. Okay, so this is a w4, k13 and w4. You have to just make like this. Okay, so this is a union graph of k13 and w4. Then next is complement of cycle graph c4. Complement as I recall, I have studied this in the last to last lecture. Complement means it's opposite. Okay, it's opposite. Okay, so cycle graph c4. Let's do cycle graph c4 first of all. This. Okay, cycle means like this, c4, and you have to draw complement. Complements its opposite. Okay, so opposite means you have to draw edges joining which is not joining in original vertex. Okay, so this 1 2 3 and 4, 1 2 3 and 4. Okay, so 1 and 2 is connected, so we do not have to draw 1 and 3 and 2 and 4. So this is a complement of cycle graph. Okay, so in exam they have asked from any of the graph we have discussed earlier. Okay, complement of cycle graph, complement of bifurcated graph, complement of null graph. Okay, do not confuse between complete and complement of any graph. Okay, so this is this 5 question is also your assignment question. Okay, you have to draw in your book and upload it in RNWIET application. Okay, so in next lecture we will discuss some of the new definition related to the graph. Okay, so now today's lecture is completed.